Welcome everyone to our day 11 of Scala programming language lectures, and today we will talk about sets, the last remaining major category of Scala collections. And it will necessarily involve some little bit of set theory, something maybe you remember from high school, maybe even earlier, actually a natural concept in general, but we'll see how it applies to Scala language, what facilities it offers us. So, we'll see some Venn diagrams at some point. So let's start as usual. We'll start with our repository. Again, we'll open up the main, right? We'll start a new file, right? I'll just have a new one, right? Scala class, and I will call it day 11 sets, and of course it's going to be an object, right? We're going to run it. So a singleton object, and we are going to run it, right? Add, and I'm going to extend app, right? And so since we want to run it. And okay, so what is it? So sets are, let's print out. So the Scala set collections classes are, well, an iterable, right? Iterable collection of with no duplicate elements. So that's a key feature. We'll see some other features, but that's a key feature, right? Okay, let's run it, see if we get any, or code runs. We have not made any syntax errors. Doesn't look like we did. So let's see if our while compiling, and it should be compiling very quickly, reasonably quickly, and yes, everything works nicely. Okay, so again, our collections, again, it comes from here, the overview, right? Remember, we have traversable, iterable, meaning we can loop through, and we saw sequences, right? And we saw maps, right? Which we had key value pairs, a collection of key value pairs, right? This is of course immutable by default, but of course we also have immutable, and mutables have a little bit more variety, right? Again, but generally for now we will use the basic set and not worry about these subtypes actually too much at the moment, right? And so again, I'll give some information. So this comes from here, and there's also a set documentation here, which is quite nice. This is documentation here, right? One of the where do you use this? So uses, right? We use for removal of duplicates, obviously, right? Makes sense. Also quick membership testing, meaning we'll see about that, how to check for something existing in a set, right? And also we can do set theory operations, things like difference, union, symmetric difference, and I was going to say what's one more. We'll see some more operations. Okay, and etc. Right? And so how do we start make a set? We'll start of course. I'll use a value constant set. So my set, and I will use a set, right? Just generic one, and I'll put some numbers, right? I put some numbers, and I have some duplicates, as you can see, but I most likely will not have all, right? And so what do you think, what will be this type? As you see, IntelliJ should tell us this is an integer, right? Because we are giving just integers. Well, if I gave it maybe 3.14, right? 15926, right? Of course, I would have, this would be a double, right? But okay, I will leave it to the integers for now. Right, again, so of course statically typed language, we have all types are important. Okay, so for now we'll just print it out, right? And we'll see the results. And run die set, and we should see the set results. So, well, you see it's actually hash set in this case. Again, we can look up our hash set here. I think we saw it somewhere here in collections, so it's a hash set. Again, specific type of set. Well, again, thing is of course sorted set by generally we don't really need in general terms we don't really want a sorted set in most cases, right? We only care about the membership there, right? So let's see, what can we do? Can we check if it exists, something exists in a number? So print line, right? We saw, of course, you see, notice there's no nothing sorted. If you want it sorted, you have to use a specific sorted set. For now, we'll use, let's check, does number 6, let's say my key, right, my needle, right, well, my needle, I'll say my needle, maybe let's say 7, right, and I'll say my needle exists in my set, right? And of course the answer will be, I'll say, will be maybe slightly surprising, it should be like this. And let's check, there are two ways of writing this in, not my needle, but my set, my needle, right? So you can write like this, okay. And that should, of course, should give us, we'll close the right brackets, and let's see if this works. It should be true, right? We have a 7, right? My needle, well, we'll see if it exists. And let's run it, see if my syntax is correct. Certainly looks okay. Yes, it is true, right? So another needle, right? Another needle. Let's say again, I'll put something like 9000 in there, right? And well, most likely, Control D. I'm gonna duplicate this line, right? I'm gonna, since I'm slow, I'm just gonna do it like this, and I will enter another needle here, right? And of course, I should have put it here as well. Another needle, right? And it should be false, right? So that is the core operation, right? False, right? 9000 doesn't exist in this hash. Okay, so again, why use this, right? So why not go through a sequence and check for something? The key is this membership testing. Tests like above should be extremely quick. In most cases, it will be so-called constant time O1, right? So again, not even on very large sets. Again, so instead of going through a list or any type of array or sequence in general, we will want to use a set. Okay, so that is one of the basic things to use. Okay, so can we loop through? Actually, since well it's an iterable, let's try looping through my set. Again, the order is not guaranteed, but let's try it. So for n, right, I'll do something like my set. Will it work? It should work, right? And again, I'll use the brackets, of course, print line, item, right, is in my set, right? And of course, I will use its string interpolation. Okay, so it should run it, and it should give us it should go through one by one, right? So we can, of course, right, is in my set. You see, notice that it matches this particular order again. So you might be saying, okay, but I want it sorted. How could I do that? Well, then we're gonna convert it to sequence, right? To an array, for example, right? Some sort of a generic, you know, some type of sequence, right? We can go back and forth. In fact, that's one of the key areas, right? We can have maybe a sequence, let's say an array, and then we can go from that and just remove the duplicates, right? So for example, you know, I can do, for example, array while r, right? And I will do it maybe array, right? Say again, I'll put some numbers, right? And of course, this is nothing special. Again, I can do some numbers, again, some duplicates, yeah. But again, and of course, print line, right? Print line array, and that should give me nicely the array. Again, that's a sequence. Well, it's actually a basic Java array, but actually we can consider it as part of sequence. Also, probably should have made it make string, right? Make string, comma, right? So we can see the values, right? So duplicates are still present, right? All right, we see 3, 3. Okay, so we'll call it, well, set from R, right? And of course it will be R2. Let's see, we should have a set. We have it, right? That should do it. No errors, right? And of course, as we know, this is nice conversion. So set from array, and we should see all the duplicates gone. Right? Do you see any duplicates? I don't see any duplicates. Okay, but you say, okay, it's not in order. Well, okay, then we can make it in order. We could have used we could have used sorted set, but those do not have the same performance as the hash set, right? As the generic hash set, right? Okay, so what we'll use instead, we'll move it onto an array. So of course, well, r from set will be what? And in fact, I'll do it set from array, and I'll do to array, of course. But what I could do is, can I sort already? Sorted, I think I can do it. I can do this. I believe it's. Is it? Do I have any key? No, I don't. Right. I also, at the same time, I also sort it at the time of conversion. Right. I say the type of conversion, and I will have. I should hopefully have line r from set. Here we go. And again, make string so we can see some results. So it should be sorted, of course, on. No, of course, this is again, that's part of sequence operations. That's nothing to do with sets anymore. But once we sort it, but let's see if that works. It should, but you always want to test. So it's nicely sorted. And of course, again, if you need duplicates, you add some more stuff. Well, again, you can go back to set and then convert. Right. Again, if you're doing a lot of these operations, maybe you need the use of R at some point, right? But of course, for now, we are keeping in with the recommendation that we use values, meaning constant references to everything, you know, unless we really need to some iterable, you know, then of course we use, then we can change the values. Okay, so we know how to test the membership testing. We can loop, we know how to loop, right? We can loop, right? So we can loop through sets, right? Order is not guaranteed, right? Specific order is not guaranteed for generic, right? For hash set, right? For hash set, right? And let me commit it, right? So this is the first stop, and I'm going to commit it. And yes, I'm going to commit set day one, set introduction, right? And we have our references, and we have the basic operations down. So that's not too bad, right? Hope you agree, and we can continue. So we can convert, right? So we have uniques. What else can we do with sets? Let's think about else. So we have contains, right? We have alternative syntax. We could do also there's alternative syntax for membership testing. And I can type, of course. I can add this here, replace with alternative, right? And so we could do this print line my set contains, right? We did this, right? My needle, right? And of course I can do my set contains and I believe I don't need this, my needle, right? And personally okay, so alternative syntax, same thing, right? So let's run it. It should be true. Again, this is more humanly readable, true, right? And this is the same result, right? So we can also do some subset testing. This will be in a second part of the lecture. We'll do. How about adding some values, right? So, well, since we are doing with while on immutable, we have to make a new set, since while using immutable sets, just like with other immutables, I will need to create a new set. So we'll do something like this: while set with additions, right? And I can do with addition. And of course I can do my set, and I can do a plus, right? I can do plus maybe 100, right? Print line set with addition, right? Of course it's completely new object, right? So I will should have 100. So 100 should be added to the set. Yeah, not mathematics, no addition, no mathematical, no algebra, no algebraic addition, of course, no math, right? Not math, right? Not math, right? Of course. Let's see if that really works. Well, it's not red, so that looks good, right? So we should be able to add it and run it. And yes, we have 100 there. Excellent. Again, so we complete a new object, right? So can we add more than one? Well, sure, why not? Let's do some more. And so we'll add set with multiple additions, and we'll do something like this. Again, let's start with this. We'll keep building up. Well, let's add maybe, I don't know, 200, 300, 150, right? So we had 2 already, so I think we had 2 already somewhere here, so it should not be added. Yeah, we did have 2. So also 100 was added, right? So these 2 and 100 should not be added, but 300 and 150 should be definitely be part of the new additions, right? So print line set with multiple additions, and let's see if we get what we expect. We can add multiples, right? So let's see if that really is the case. And indeed, again, order is not guaranteed. Notice, right? Again, if you want order, you go to some sort of sequence, you sort it, and you'll have a sorted sequence. Again, so that's what we have here. Can we do removals? Right, we don't like, let's see, we don't like 9, right? So how do we remove it? Well, set after removal, set after removal, right, will be, of course, set is multiple additions, and I will take what you expect. Well, we'll use a negative, right? We will use a negative sign, and I believe this was, I hope it's still, yeah, it's still available, and I will remove 9, right? So 9 should be removed from our collection. And again, one thing we haven't removed, what happens if we remove something which doesn't exist? Will it have an exception? Which of course is common in Java world, but we try to avoid in a Scala world, and maybe we'll test it afterwards, right? That's something I have not tested recently. Let's check, right? So we'll see, this should have 9 should be removed here, right? So we have 9, it should be gone. Is that the case? Indeed, 9 is gone. Well, okay, since I'm lazy, well, let's see what happens since I'm gonna do it here. Basically, can I do this again? Is it gonna be an exception or not? And I'll do -9 again, right? Theoretically, it shouldn't break anything. I'm not saving it, right? I'm lazy, but we'll have an exception. Well, let's see if it does. If it does, we'll have to make a note of it. No, there's no exception, so no exception. So no exception on removing something that does not exist. Of course, also, similarly, we saw that there's, well, which would be, it's nice that we don't have an exception when we're adding something. That's, of course, is part of the set collections idea. You can add something, and if it already exists, there will not, it will silently add what's needed, right? So we only had 300, 150. These 2 are ignored because they already exist, right? Here we remove 9, and here we don't. Here we have a new object, right? Which I'm not saving, but it stays the same as this set here, of course, because 9 doesn't exist, right? So there's no error, everything is completely fine. Okay, now let's see, can we remove more than one? Well, set after multiple removals. So what can we remove? Of course, we'll have a set after removal. We'll try, right, and we can use what? Minus, and as you can imagine, we'll use this parenthesis to indicate multiple. I'll just type some numbers, right? Nothing special, maybe 2, 5, 9, and maybe will we have anything left? We'll have something left, right? So let's see, do we have this? What will be left? Set after multiple removals. Let's see if that gives us the needed value. So we expect that these 1 and 2 should be removed, and well, 5 doesn't exist, but it shouldn't draw error. Remember, notice we are removing some items that do not exist, which is fine. Well, I'm saying fine. I'm reasonably certain it will be fine. There are some warnings. We'll check that also, which is possibly there's some depreciated methods. I think the negative was slightly, I think this was depreciated. Yes, I think it was. Yes, it was depreciated. What does it mean depreciated? That was because, well, it's not considered the best style to write it with a minus. Again, maybe somebody complained. Notice again. So 1 is gone, 2 didn't exist, 2 is gone, 7 stays, of course, right? 5 didn't exist, no problem. 9 did exist, 9 didn't exist, but no problem, right? We already removed earlier, right? And 100 existed, we removed. So that's all good. Well, unfortunately, like I said, I like using this syntax, which I've grown used to it, but it's not considered the best. Let's check what it offers, what I should be doing, right? There's some warnings. So what should I use is, right, immutable set, right, depreciated, right, the set operation possibly is, let's look at these warnings, right, plus is also depreciated, unfortunately, right, so these two symbols, right, this plus and this minus, right, it's interestingly enough that this works fine, but just for multiples, right, so for singles it's fine, for these it's not considered good, right? In fact, unfortunately, the sad thing is that this is actually in official documentation, right? So if you look, I think somewhere here, I believe somewhere it is here, right? You see, it's still an official documentation, so I'm not doing anything out of ordinary. So again, so what does it mean? The interception, well, depreciate, what does it mean? That means it might not be supported maybe in some newer Scala versions. Right? Maybe Scala 3 might not support actually, right? Remember, we are working with Scala 2.13, right? The latest stable version from the Scala 2 family. So let's check, can we find something better? Well, unfortunately, it doesn't offer, can we convert to block expression? That's not really what we want, no. Can we change it to something better? Remove, oh, well, that might be left for another part of the lecture, right? So for now, again, so would it kill? Control D, right? I'm going then Control D. I'll do again after multiple removals, right? And I'm going to of course copy this and let's see. I believe it was remove. Let's see. Do we have any sets? What do we need to? Can we do something? Remove. Remove. No. Negative difference. No. Yeah. Fortunately, maybe I guess. Can I do set? Would that help? Yeah, that works actually. That looks like it's a. So that's the recommended way. So I think the problem was that you're not supposed to do this lazy way anymore, right? There is supposedly some argument why this should not be. So you need basically another set, and then you can do this. But this, of course, will be a set operation, of course, right? This will be a difference, right? So you keep everything here, which is not in here, which makes sense, of course, right? Because this is actually already part of the set operation. So yes, we will fix that. So this is recommended. So recommendation. So recommendation now is for set difference is to actually declare a real set, right? So this should work. Let's see again. It should be exactly the same. Let's see. Or use it, of course, right? And there is a mismatch. Let's check what's happening here, right? And actually it doesn't work. Type mismatch required integer, right? And it's actually, yeah, so this magic doesn't work. So this doesn't really quite work, unfortunately. So we are left with some, right, so we need to use this, I believe. Let's check this one. I believe this was a minus. Yeah, so this was actually in documentation. Let's see, this will it work? Yeah, it works fine, so this is recommendation. Yeah, unfortunately. Like I said, it's still okay on older code, but for newer code, it's not as, you need to use this syntax, right? Okay, so we'll get back to set operations in a moment. Okay, let's check briefly, since we how much time we have. We have time on, we're running for now 24 minutes. Let's do some more. Let's check what we have on mutable sets. We can also have mutable sets, right? Of course, as by now you already well know, pretty much everything has a mutable and immutable set, so I'll call it mute set. And we'll have, of course, use it since we have not imported anything, I'll go Scala collection, mutable, small mutable unset. As before with sequence and maps, we need to declare style if you're going to start with a blank state. You know, tabula rasa, I'll do integer. And I'll do, of course, so this is blank. So we start with an empty mutable set. Okay. So, of course, we can do print line, right? On my mutable set, right? Let's do it. In fact, I should have, of course, committed this at this moment, but well, again, we'll do multiple commits at the end. Right, so empty hash set, right? But it's mutable, right? We can't see it from here, but it's mutable, right? You can see it here. Well, we can't really see it, but we can see it here that we can do things like this. Mute set and plus equal maybe 5, right? Mute set plus equal 3, right? And mute set plus equal 5 again. So we should have 3 and 5 on print line, mute set. So we should expect that adds to the set, and of course we need no typos needed, and we can add. So we should expect it should see 3 and 5 here, right? And let's run it. Indeed we do. Excellent. Right. So we can add things from multiples, right? Let's try adding some stuff from array, right? So we could do an array or sequence, right? So I could do things like this, mutable set, and I could do plus plus equal, right? Multiple, right? I can add, I'll do array again, 3, 5. Well, I can do, of course, maybe I'll do something like this, 0 to 10, right? To array, right? And let's see. So what I do is I'll have a set of all numbers from 0 to 10 included, right? Of course. So 3 and 5 is already there. That's so those will stay, right? So we need to, so let's see, print line, mute set, right? And let's see, we're creating basically array on a fly, so to say, we're getting a running start for our array creation, and we are adding it immediately to our mutable set. And here, of course, it's nicely ordered, but that again is not a guarantee by any means. Of course, let's check, let's add again something silly. So I can do something plus equal. I can do array, maybe 9000, 9001, and again maybe 5, right? And of course, again, only this 5. So again, only new unique values will be added, right? So again, and I'll add another 9000, of course, right? So again, only these, we expected only these two should be added. These two will be ignored, right? So let's see, line mute set, and let's see if that's the case. And as we can see, yes, it is the case. And of course, or nicely, the cherished order that we thought is gone. We have again, no guarantees in a generic hash set, right? We just have a, well, we can think, okay, maybe it's alphabetical, right? Maybe there's some order behind the madness, but again, we don't really, that's not what a generic unsorted set is for. It's actually for membership testing and for set operations, which will be our second part of the lecture, but we're almost done with the first part. So we can also do methods, right? We can add methods. We can do this, which is basically mute set, add. Yeah, we can do add, right? We can do it like this. Yeah. So we basically, so just like plus equal, right? And of course, mute set add, say 15, right? So we should again, so we should see print line mute set that only, since we have only 15 should be added, since 10 already existed, right? So let's check if that's the case, and we are almost done with the first part, right? So 15 is added, 10 was not added because it is already there, right? So simple. So if there is add, what do you think? Is there a deletion? Yes, there is, and that should be basically, let's move some numbers. So we do mute set minus equal, again minus equal 7, right? That's fine, right? I can't, of course, remove all this, right? Because that would be a type mismatch, right? Technically, right? It doesn't say though, but that's not good, right? You can't do that, right? So we need to actually remove the, well, even though the IntelliJ is not yelling at me, but that's not a good idea, right? So removing 7, and also we can do mute set remove, I believe. Yes, remove element, and we'll call it maybe 3, right? Okay, so we should see 2 and 7 both similar, same as above, right? Same idea as previous line with minus equal, right? And again, as usual with Scala, you have multiple ways of doing things, but they're both, I think, quite logical, right? Set, right? So again, so what's the difference again? So mutable set, it's constantly being changed, right? The size grows. Of course, we didn't check the size, by the way. Let's check the size, right? Mute set, right? And we should be able to see the length, right? So we have 2 is gone, Mr. 7 is also gone. So size of mute set is, let's try it, mute set. Do we have length? We should have length. I like size, but I think length is available. No, it's not actually available. I thought there was an available method, but apparently it's not. Maybe size is there. We maybe need to convert it. Wait. Really? Size is available? Okay, I guess size is available. Let's check if there's going to be any warning. I thought there would be. So how many there? How many members are? 12. Looks about right. 3, 12 members, right? Okay. At the moment, and the moment is okay. So we're almost done. We can completely clear the set, right? Of course, I can do this, right? I can completely clear the set. Clear, right? Again, since it is, I like using not, since there's no arguments, of course I could use empty parentheses. I'm just gonna use like this, and of course, as you can imagine, print line, it will be size of our set is 0, right? I'm sure you're gonna trust me on that one, but we are gonna check, right? And of course, we will do with print line mute set. It should be completely empty, right? So remove, right? And it should be completely empty. And it is done. Great. So our next steps, what are our next? So we saw how we can add remove member items to our sets. Now next step will be, we saw how we can add and remove sets members items to sets. Next step will be to explore some set some operations from set theory. But again, that will be the second part of the lecture, so I will make a stop and commit now. So there's my commit. There we go. And set introduction, set operation, set creation, set addition, and removals, right? Commit and push. Thank you for being in the first part of this set lecture. Hope it was you were able to follow. If not, check the repository and we'll maybe go slowly over the lecture again. And again, we'll continue with the set of theory operations after the break, a short break.